going to predict whether precipitate forms. And if you have to take chemistry in first year, this will be, or if you ever have to go and do a lab or be part of a lab where you are making a solid product, then this is going to be an important calculation, because when you have precipitation, it's going to require a certain concentration of ions. So we're going to look at another trial value. The reason it's called a product instead of reaction quotient, the Q, like we did in the first section, if you multiply numbers, what's the answer called? Product, okay? So same ideas. The solid is always the reactant, which means we are never going to have the bottom in our ratio, because you always, or you never include solids in the equilibrium law. And then the two ions, the cation and the anion, will be on the right. So we're going to, just like last time, substitute given concentration values into the solubility equilibrium law expression to produce a trial value. So we're going to input the concentrations and calculate a value for Q and compare it to the given KSP. So when you do these questions, if you, again, do not have an extensive, or if you do not have extensive experience with scientific notation, sometimes it can be difficult to figure out which number is bigger and which number is smaller, okay? And just like last section, when you calculate Q, can't spell no. No ice. In the last topic, we would have done, the question would have said the math is out of 2 marks and the explanation was out of 3. You had to do the Q calculation, and then you had to do, like, is it going to shift left? Why would it shift left? These questions, which stood out, is the system at equilibrium. That's not normally what the questions look like when you had to do an ice table. Today's are also going to look different, because the question's not going to ask just about is it at equilibrium. It's going to ask, does a precipitate form? So you have to say one extra thing. So if it shifts left, yes, a precipitate forms because the solid's on the left. If it shifts right or forward towards the ions, that means no precipitate. So we're going to look at different situations and different conditions where precipitation could occur, and then including mixing 2 solutions together, which is really, it's going to require quite a bit of math, but it's really the most important. And then the last example is called common ion effect, and this has implications because if you have a situation where you would like something to precipitate, or if you have ever seen a situation where you put something in and it almost looks like the crystal is growing, it's because precipitation is occurring. If you were in my grade 11 class, we did that last year, but we used temperature where we cooled it down and you saw where the snowflakes formed. And so there's lots of different ways to get precipitates, but if you would like to be very quantitative about it, then that's what we're going to do today and tomorrow. And tomorrow, when you mix a solution together, we have to do an extra calculation. So I think you'll be able to see when we're done tomorrow that why I split this section apart. Or you can imagine if we had 2 tests, this giant unit test, that would be a lot of word problems and a lot of math. Okay, so today isn't so bad. I encourage you to do as much of. We're going to do topic 2 today, and then 3 and 4 tomorrow. We're going to do a lab on Wednesday, and I'm just trying to decide. I used to do it before, and the observations and the calculations, the pre-lab calculations, used to take a whole period, and I would rather it was a bit more streamlined, so I just have to decide how that's going to work. And so what you're going to do is figure out, use math and predict where a precipitate should form, and then prepare the tubes, prepare the solution, and see if it works. Okay? That's what we're going to do. So if Q is equal to KSP, then the system is at equilibrium. That is very boring, but it is a thing. In a saturated solution, which is the definition of solubility equilibrium, then when you have a saturated solution, you cannot see, there's no precipitate in there either. Or in that type of solution, saturated means the maximum amount that is dissolving implies that there is no precipitate. The solution or the solid has been able to be hydrated by the water. It will be the other two conditions that are more interesting, okay? So Q greater than KSP and Q less than KSP. So just like last time, you can use the alligator signs or not. It's up to you. You can use the words. So if Q, it's the same principle that if Q is greater, then our number needs to get smaller. So if you like to think of a ratio 1/4, 4/1, the bottom needs to get smaller. The weird thing sometimes here is that when you have KSP, we don't really think about the bottom because it's a solid reactant. But the principles, the mathematical principles, can still be applied. If you want your number to get smaller, you have to make the top of the fraction bigger. I mean smaller, sorry. So if you would prefer to not write the both ways like we did last time, we can do that. So it says the system has to shift left towards the reactants. So if Q is the product of the cation and the anion's concentration, then we need this to get smaller so that our value will get smaller, okay? Which means that if you want less ions, then you have to shift away from the ions, which means you're shifting towards the solid, okay? Okay, so when the Q value is too large, the system needs to decrease the ion concentration, which are the products. So the shift must be away from the ions towards the reactants. So we would have said that type of answer in the first chapter, first section of equilibrium. Now we need to go one step further. If you're shifting to the left or reverse, then the reactant is always going to be the solid, and so you're going to get more solid formed or more precipitate formed. Okay, so then when our number, our trial value is too small, then we need what is being multiplied to get bigger in order for our answer to become larger. So in chemistry terms, that means we need the cation concentration and the anion concentration to increase. So now, because ions are always on the right-hand side or the forward direction, we have to shift to the right towards the products. So if Q is less than KSP and you have to shift to the right, then you're not going to get a precipitate formed because on the right-hand side is always ions. So when you write your dissociation equation, you have to put S and AQ. If you forget about the charges, that's okay, but you need to know where is the solid and where are the aqueous ions, okay? Okay, so the question could be very, very, very simple like this. This would probably be out of, like, maybe the math would be out of 1 and the explanation could be out of 2 or 3. Okay, so I give you the Cu and the Cl concentration. I didn't even, it's already split apart. You don't even have to write a dissociation equation. And it's going to ask, will a precipitate form? So we have to figure out if it's going to shift right or shift to the left. Okay, so again, no ice. We're given KSP, we are given a concentration. It doesn't say that it's molar solubility. You don't know. Okay, so we're going to calculate Q. Okay, so when you have this answer, Q is 1.68 times 10 to the negative 7, this number, because it has the same exponent, then you can actually just look at the size of the number, which is unique. Normally you can't do that. So this is smaller than 1.9, so that means that Q is less than KSP. You can also just subtract. So if you're very stressed about it, if you put Q first, and you subtract and you get a negative answer, then the Q value is too small. If you subtract and it's a positive answer, the Q value is fine. Okay, so that is one difficulty here, that Q and KSP are usually in scientific notation. If your calculator allows you to switch between them and the number of digits is not too crazy, like this one, most calculators probably would convert these into standard form, not in scientific notation. You can certainly do that, but most calculators, if the KSP was like negative 12, for example, most calculators would have trouble reporting that many digits. So it would be in scientific notation. So, maybe it's just do your best to get used to it. Okay, so Q is less than KSP. So our number needs to get bigger. So again, if you like 4 and 1 and 1 and 4, 4 over 1 is 4, 1 over 4 is 0.25. So we need the top of our fraction to get bigger. So that means that we need the products to increase. So the products are always going to be ions. And you could say shifts towards the products, that's fine. You just have to make sure then you say, is a precipitate going to form? No, because the ions are products. Okay? And then the other type of question we're going to do today is something like this. So again, if you are in a lab situation and you have a solution that has no solid in it yet, then you can calculate the value where you can add one more crystal above that value and you would get a precipitate formed. And there's lots of solids that it's like, once you get a little bit of crystal, then it starts to, it's like a chain reaction, and then you get lots and lots of crystal. So forming a solid sometimes is advantageous, sometimes not. So maybe you would use this the other way. I'm going to keep my concentrations below this value so that I don't get precipitate, okay? So when you do a question like this, we're going to find where Q and KSP are equal at what concentrations, but then this question says just to begin the precipitation, so it actually needs an answer statement. Anything above that value will give you a precipitate, okay? So we have the silver. We are going to calculate the chlorine or chloride ions, and then the value is 1.77 times 10 to the negative 10. So this is, the math part of this is very simple. Except that you have to, your calculator probably can't deal with this number as a standard form. You'll have to use scientific notation, and then you just have to divide, like solve for the x, which is going to be the chloride ions, and write an answer statement. Okay, so all we're doing is subbing in what we know. We know KSP. We know the silver, we don't know the chlorine or chloride. Okay, show all your work like you're back in grade 9 math, maybe even grade 8. You can write capital M or moles per liter. It is concentration, so this time it should have units. So if you find where the two concentrations multiplied together will give you KSP, technically there is no precipitate at this value. So in order to fully answer the question, you need an answer statement. Any concentration of chloride greater than this value, more than this value, above this value will give a precipitate. Then the Q would be the concentrations multiplied together, the Q value would be too big and it would have to shift left towards the solid. Okay, so the homework for this section is topic 2.